Hey guys, you ready? So, uh, probability of C. Add the two numbers together. How many numbers are in C? 0.4 and 0.2. So what do you think we're going to get the answer for that? 0.6. Okay, that's your first one is 0.6. We're going to do the same thing with D. So what do you think D is? 0.5. Okay. C union D. That's C or D. So you have to add all three together. 0.9. Yeah. And then C intersection D. The middle. 0.2. Oh, lads, verify the following. Okay. What's the answer for that one again? PC? PD? 0.5. Take away 0.2. 0.9 equals 0.9. All right. Next one. Okay. I'm probably going to draw a Venn diagram for this. I might draw a Venn diagram anyway. I'm visual learner, so fair play to you if you're smart enough just to do it off the cuff, but I might be thinking otherwise. So here's what I'm thinking. Probability of A intersection B is 5/12. Right, so everybody happy with 5/12 in the middle? Okay. And everybody happy that that's A and that's B? Okay. What it says is A has to add up to 2/3. So the full circle has to be 2/3. You got that? So I'm going to do 2/3 take away 5/12. Why am I doing that? Yeah, I'm trying to find what's in here. So when the two of them add together, they give me 2/3. So common denominator, that'd be 8/12. 8/12, take 5/12, 3/12. 3/12 is a quarter. Okay. Now, next thing. I'm looking at the probability of. I don't know this region here, do I? But what do I know? So if the whole thing's 3/4, that means 1/4 is on the outside. Yeah. So it means I'm going to add a quarter plus 5/12. A quarter plus 5/12 plus x is 3/4. Agreed? 1/4 plus 5/12 is. Oh, we already have that. It's 2/3, isn't it? So 2/3 plus x is 3/4. And then I'm just going to do 3/4 take away 2/3. And what's that, guys? 1/12. Yeah. Now, I still haven't got my answer yet, though, lads. I'm looking for PB as a whole. Had to add 5/12 to 1/12 to get 6/12, otherwise known as 1/2. So, Venn diagram again. Okay, and I'm just going to draw how many of them? 2 of them. Okay. You see, the solutions doesn't do it this way, but this is just the way I prefer to do them. Okay. So, what do we call that? C and D. Now we have the middle again, don't we? That's 0.3, which will make this 0.4. How do I know that? Yeah. And this has to be 0.2. Why? All three of them have to add up to 0.9, and then the outside would be 0.1. And then just wants what D is. Add the two of them together to get 0.5. So much easier in decimal mode than it was in fractions. Okay. So I'm probably going to do the diagram again. If it's mutually exclusive, there will be no intersection. You got me? So here's where you go. And I say A and B. Okay. There is an intersection. Okay, but I probably have to prove it using the prove it using the proof. Okay. Now what happens here? What's A15's take away 1/3? Huh? Oh yeah, you're right. 3/15, which is A15's take away 1/3 is going to be, when you put it into your calculator, it's going to be What do we say again? 3/15, which is a fifth, yeah? What do we, 2/3 take away 1/3? Because you're finding out what this is? Another third, yeah? Okay. So mutually exclusive means probability of A union B is the probability of A plus the probability of B. Is that okay? And I think actually, one sec. Oh, once we define A union B, that's the part one. Intersection's dead center, and union is the three regions combined. Intersection be 1/3, and union would be a fifth plus a third plus a third. And what's a fifth plus a third plus a third? Anybody? 13 over 15. Is A and B mutually exclusive? I'd say no, because A intersection B is not empty. See that signal there? That means it's not empty. A intersection B is not empty. Or you could just explain that in words. A intersection B exists. This means that it cannot be mutually exclusive. Is that all right? These aren't bad. All right, this one hopefully has a bit of substance to it. 50. I'm going to put 50 here. Why? 50 teenagers, yeah? Do I went to the cinema or do you watch movies at home? Or both? Over the weekend, the phone data was collected. B intersection A? 25. Oh, this is a tricky one. What does this mean? So B dash means everything outside of B. You got it? Everything outside of B that's also in A. So the answer to that is that means this whole part is 10. Because B dash means everything outside of B. So for example, if I had the number 15 on the outside, everything outside of B would be the 10 and the 15. But it says intersection A means it has to be an A. So that's where I got the 10 from. Is that all right? Has to be an A. Now, next part. Everything that's outside A, intersection, everything that's outside of B. So what does that mean? 10 on the outside. It's a fancy way of saying 10 on the outside. Everything that's outside of A and everything that's outside of B is the 10 on the outside. Right, we did part one, didn't we? Describe the set of students of A intersection, intersection, B intersection. Sorry, A dash intersection, B dash. That's the 10 people that didn't go to the cinema or watch movies at home. They didn't watch anything. That's exactly what I say. This set means the people who didn't watch anything. You don't, well, whatever. Well, then they don't like watching. Yeah, the students that didn't watch any movies. Using the data, redraw the Venn diagram, inputting the probabilities. Okay, we have to do the probabilities now. Okay, so 10 out of 50. Oh, wait a second. I'm not complete yet, am I? It is 5 because it has to add to 50. Okay, now let's do the probability. Okay, probability. 10 out of 50 is 1/5. 25 out of 50, 1/2. 5 out of 50, 10th, and 10 out of 50, 1/5. Okay, that's not bad. Using the Venn diagram, find the probability that here's a student who went to the cinema but did not watch movies at home. Cinema only is basically what that says. What's the probability? 1/5. What's the probability of egg? 1/5 plus 1/2? 7 over 10. Because it's both of them added together. Probability of egg. Probability of big? 3 over 5 or 6/10. Okay.